Remember how ChatGPT appeared randomly out of nowhere in late 2022 and gained like 100 million followers in a month? Yeah, I kind of feel like Microsoft is working on something similar. Or maybe I could be just completely wrong. Just stay tuned to find out. When we think about Microsoft, the first thing that usually comes to mind is Windows, Microsoft Office, and Xbox. But behind all of that, there is something much more bigger: infrastructure. The invisible systems that store the world's data and keeps the internet running. Everything digital needs a physical home. Your photos, your emails, your videos, your bank records, they are not all just floating in the cloud. They live inside massive buildings called data centers, which are filled with computers that store and process information. These buildings generate heat, like a lot of heat, and also consume a whole lot of electricity. So data centers need to stay cool all the time. They use electricity to power the machines and even more electricity and water just to stay cool. And the storage systems inside them don't last forever. Hard drives wear out, mechanical tapes degrade over time, and servers need to be replaced every few years. Imagine if some data centers didn't need to be powered at all. I think this was the question which led to Project Silica. Instead of saving data on metal discs or plastic tapes, Project Silica uses glass. Very pure quartz glass, similar to what is used in microscopes and satellites. A laser is used to write inside the glass and not just on the surface. The laser creates tiny dots at different depths and angles. Those patterns represent ones and zeros, the language computers understand. You could think of it like carving information into stone, but at a microscopic level. Once the data is written, the glass doesn't need electricity. It doesn't spin, it doesn't degrade, and it doesn't heat up. It just exists. The glass can sit on a shelf or in a box at room temperature for hundreds or even thousands of years at a time. When the data is needed, another system shines light through the glass and reads the pattern. It's kind of like reading a very advanced barcode. But the ideal question behind all of this is simply, why does this even matter? Well, it's simply because a huge majority of the world's data is cold data. Cold data is information that must be kept but is rarely accessed, kind of like historical videos, medical records, historical documents, or the Epstein files. Today, we store data on machines which are powered and cooled 24 hours a day, even when no one is using it. With glass storage, that energy consumption drops dramatically. Okay, let's think about this in practical terms. If a single piece of silica glass could store 7 terabytes of data, then just 150 pieces of this glass could store a petabyte of data. Today, storing 1 petabyte of data requires multiple racks of server space, constant power and cooling, and dedicated storage space. With glass storage, that same amount of data could be stored in a small cabinet or safe instead of an entire room. At a large scale, moving just 20 to 30% of the internet's core data into glass storage could significantly shrink the size of data centers, cut down the number of always-on servers, and reduce cooling energy need by a massive margin. It's not practical yet, but given how fast technology is moving, I think this is less of a matter of science fiction and more of something which could be possible in a few decades ahead. In late 2020, Apple designed custom silicon processors for all of their computers, and it took the world by storm, delivering desktop-class performance while maintaining iPhone-level power efficiency. Their laptops became faster, cooler, and way more powerful overnight. And up till today, the Apple M series chips are still the most powerful and most competitive chips in the world. And if you thought that was impressive, then you're probably not ready for what I'm about to tell you. I heard that subscribing to the channel is like 100% off today, so you could try by clicking the button below. Imagine a processor with the computational power which is far greater than all of the computers in the world combined, on a single chip which is small enough to fit on your hand. Wait. I think you didn't hear me. All the computational power of all the computers in the world, all of the computers in the world combined on a single chip. That's what Microsoft has been working on. In order to understand why this matters, we will firstly have to understand how computers work today. Every computer you've ever used, from your phone to the world's biggest supercomputer, thinks in ones and zeros. Even when we make them more faster and more efficient, we are still just simply stacking more of the same technology on top of itself. For certain problems, even the most powerful computers in the world right now would take thousands or even millions of years to compute it. This is where quantum computing comes in. Traditional computers think in bits, where every piece of information is either a 1 or a 0 and nothing in between. Quantum computers, on the other hand, use qubits. A qubit can be a 1 or a 0 or both at the same time, thanks to the weird laws of quantum physics. This allows quantum computers to be able to explore multiple different possibilities at the same time instead of one at a time. And this is why, in theory, a lot of people think that they will be dramatically faster than traditional computers. But there's a problem. Quantum systems are very fragile. The smallest vibration, heat change, or electrical noise could cause errors. Most quantum computers today are incredibly difficult to maintain and break down easily. Microsoft decided to take a different path to this. Instead of trying to fix the quantum problem with more and more software, which is kind of like trying to fix an airplane with a shoelace, Microsoft asked a deeper question. What if we could make quantum computing stable by nature? That's where the Majorana chip comes in. I pronounced it well this time. The Majorana chip is based on a special quantum state which is naturally resistant to noise and interference. You don't have to understand physics to understand why this matters. It simply means that the information is much harder to mess up even when the universe tries. Think of it like this. Trying to operate a quantum computer today is kind of like trying to balance a pencil on its tip. It's almost impossible. One small vibration, one tiny mistake, and everything falls apart. Microsoft is trying to build something which is similar to a brick sitting on the ground. You can sneeze at it, bump into it, or even look at it funny and it still won't budge an inch. To do that, they didn't just tweak on the existing tech. They had to create an entirely new state of matter which they are calling the topological state, which allows quantum information to be stored in a much more stable way. If this approach works at scale, it could unlock quantum computers that are not only insanely powerful, but actual reliable machines which are able to solve problems at scale without needing insane amounts of maintenance and power. Just like glass storage, this isn't something that you're going to be seeing anytime soon. Just like glass storage, this isn't something you'll be buying anytime soon. The Majorana chip is still an experiment and still very complex. It may take many decades to fully mature, but that's the pattern with technology. Microsoft isn't just working on flashy demos, but they are working on long-term technologies which could change the next era of computing. Some of the biggest changes don't usually arrive with noise. Sometimes they arrive quietly. Thanks for watching. And cut.